All right, guys. So we are now back on the final data set that we have prepared with all the vector information in place. So let's see what the schema looks like to us. So like I mentioned, each vector is coming alongside with the column name. So we are pretty good with our feature set that we can feed into machine learning model, which is in this case is going to be a logistic regression model. Excuse me. The only issue remaining is the class, which we have seen is not in the numerical format. So obviously, once we need to feed it into the machine learning model, we need it to be converted into the numerical format, so it can fed into the training set, and then once we get the outcome based on our test set or even the validation on the real set, we can get it in the similar fashion, right? So that's where we're gonna actually start with this video. So let me convert it into the SQL view, and I'm just going to, because I also need to change the data type for some of the information which is coming as string, and you can see the education number is one of them. And like I mentioned, that at the time of loading, it has been given the string data type. So we can change it into other data types if we have to. Similar way with hours per week, we know it's a numerical value, like nobody can work in the textual hours. We normally calculate based on the numeric value, so we are converting them. Obviously the age has been considered as a numerical attribute as well, or feature as well. So that's why I'm actually using the SQL to convert the data type, and then we're going to actually read it back into our data frame. So you can see the rest of the vectors are going to be same. We are not going to change them. And obviously we have one thing which we are going to do. We are going to replace so we are using the nested function in here. There are a couple of reasons for somehow that greater sign and the less than and equal sign, they are not they are not picking up within the comparison operation. So that's why instead of we checking the condition, we have the function as well which can replace the value from one value to another. And because in here we only have two classes, so it would be easier for me to go and to replace the data based on the value, because the values are limited and we know the value is not like the conversion is associated with the condition, right? We need to unconditionally, like wherever it's going to find greater than 15K, we called it class 1, and where it's going to find less than 50 or equal to 50K, it's going to associate 0, right? A very simple conversion. And then the rest of the values going to remain same. We are not going to touch them because we have already prepared them. And once we convert this, let me just quickly run to see that whether my outcome has any error, because if you find any error, you're going to find at this stage, right? Once it is converting and returning the data, if there is any error, maybe some string value occur, then it's going to actually give you the error on those values. So it looks like we are pretty good at this stage. We are not facing any issue. Our vectors are ready, our data types are ready, and our class is ready as well. So let me just go, where is my class? You can see class is coming as and I think, yeah, that's the class output, which is more like, let me just put what I'm going to do. Let me see. No, I don't have that near. Yeah, I'm going to do just to show you. Right, we have the class, sorry, we have the class and we have the class output. Class output is more like the representation in the numerical format. So let me rerun it now, and we're gonna see side by side whether our condition is working. Sweet, we can see that our less than equal to 50K, it has been translated into 0, and I do believe where we have greater than 50K, that has been translated into 1. So our data is fully ready, and now we are going to load it back into the data frame. So you can see I'm using exactly the same theory to load my data back into my data frame. So, and I've just called it data df adult data vector prepared. The only difference going to have now the right data types and obviously the target variable or the class in a true format. So let me load the data frame, and I'm going to show you the schema just to show you the data types are converted. So you can see age, education number, hours per week, they are all converted into correct data type. And now we have the new column called class underscore output, which we're going to actually use as a target variable for our machine learning model. All right, and last but not the least, from the data frame perspective, we're just gonna see the data just to do a sense check. Yeah, I can see the values are correct. It's not like the values are twisted, and we can see the class output, and obviously then we have the vectors as well as the corresponding numerical columns. So far so good. And now I'm just going to check the class balance, that okay, whether our data set is balanced. And unfortunately, our data set is not balanced. Now, why I'm doing it? You need to remember one thing, that if your data set is not going to be balanced, it has an impact on the accuracy of your data. How we gonna do it? We will see once we come towards the accuracy part of the machine learning, which is one of the biggest, I would say, exercise while we implement the machine learning modeling. And obviously, it's a continuous process because we continuously improve the accuracy of our model. All right, so we can see we are greater than 50K. We only have 7,000 more and so instances. But on the other side, with the people who are earning less than 50K or equal to, we have 24,000. So the data set is not balanced, and I'm going to show you how it's going to impact on the machine learning model at the later stage. So just to cross check whether all our class from these textual values converted to the numerical value correctly, so we can match the count. So yeah, the counts are coming correctly. You can see we have 24720, which is obviously representing less than equal to 50K, and we have 1 which is representing to greater than 50K. So we are good at this part as well. And now we are starting the real show, not real show, now we are starting an other stage of the show, where we are now going to assemble all our vectors into our data frame into one column, and then obviously that column with the output column is going to be feed into machine learning model. We have seen the approach, and I think in most of the algorithm we're going to discuss in next couple of videos, the approach will remain same. All right. So obviously there's no wonder, like you can see, we have age column, education numbers, hours per week, and then all vector columns that we have created as part of the one hot encoding exercise. So we are now feeding it into we are assembling them. We are stitching these values together to build one feature vector, which is going to be used by our machine learning model. All right, and we call the column name as features, right? We are discussing the linear regression as well. All right, and then obviously we are going to, it's going to return me once we provide these input column and output column information, we're going to get the object that has the transformation function, and obviously that transformation function requires the actual data frame. Okay, where is the data? And data is sitting in the data df adult data prepared, right? So we're going to pass that data frame, and that's going to actually apply all the mechanics, like it's going to stitch all these vectors, and then it's going to return us the output feature beside all others column within that data frame, and I'm going to show you in a moment. So we are overriding the data df adult data vector prepared object, and now I'm going to just display those two new variables that new one variable with the outcome variable. So you can see we have all these variable, and you can see the feature length has been increased from I think number of columns were maybe 10 or 11 to 82. And that is because of the categorical column, because we are using the one hot encoding, and that is really increasing the number of features in the data set. So always remember, once we discuss that, okay, we have the 100,000 of features. So that is really depending upon what kind of data we are getting and how we are translating that data for our machine learning model, right? So keep that in mind. And obviously it's saying it's the sparse because, like I mentioned, the values are going to be on one place. It's the other place are going to be empty. And then we have the associated class output, right? For this particular record or the feature vector, we have the outcome 0, right? And we can even count that. Let me see if I can, yeah, I think just for our own understanding, we can check the count as well the same way, and we have 32,561 record, which are the sum of these two values, right? So everything looks good up to this point. Now I'm going to obviously get only these two variables or the attributes of my data frame, because these two are going to be feed into the machine learning model. So I'm just creating a new data frame, LGR for logistic regression modeling. For LGR model data frame, I'm just using these two attributes or column. And once I have loaded it, I'm just going to show you. Let me see, did I run it? Yeah, let me run it again. Yeah, I think now it's better. Yeah. And now I'm going to show you, yeah, the feature vector is ready to feed into with the corresponding output. Obviously, once we reach up to this point, the next thing is to split the data frame into into a chunks, so we can validate the accuracy of our data. We normally use another concept called cross validation. I'm not going to use it in here, but keep in mind we're going to actually discuss, because that's a very powerful technique to check the accuracy, or to once we run multiple model together, that cross validation really give us the metric that we can use to find, okay, which algorithm we are going to use for our problem set. Because remember, with the classification, obviously we don't have one algorithm. We have the logistic regression, we have the random forest, we have even decision tree, and we have the sport vector machine. So all these algorithms provide the classification, and we have even nearest neighbors as well, right? So okay, nearest neighbor that we're going to actually see. So with all these algorithms, sometimes we need to find out which one actually working best with the data set, and that's where the cross validation comes into the picture, right? How it works, we're going to see in the future videos. But it's more like, the splitting of the data into uniform buckets, so we can use it to validate the outcome of our model. All right. So at this stage, if I actually tell you that I'm going to use cross validation with the value of 3, because what I'm going to do, I'm going to actually divide it into 3 frames, and obviously each frame we are going to use for a different purpose. The first frame is going to use for the training, and it has the most record, which is the 60% of the data set. And then obviously we are keeping 20% for our testing, and then 20% for our validation purposes. So all good, and I can show you the training information. The count is 19,612, and obviously the columns are total 2, because we only have features, which is the feature vector as well as the output column. All right. Again, I'm just want to show you the training output class, because these are the class information that is going to train our logistic regression model. So we can see we have 14,880 with 0, which means people who are earning less than 50K. And then obviously we have 4,736 record, which showing us that we people were earning more than 50K, right? Now keep that figure in mind, because you're gonna see the impact on the accuracy or the prediction of the model, especially with in this context. All right, and now we are calling, like I mentioned, although we discussed the math and the inner working of the machine learning model, but you can see we normally, because all these models has already been implemented for us, we just need to prepare our data in a shape that can be fed into this model. And once our data is ready, we just call the model, and it's more like, for you, you can say it's more like the nice car which has all the engine in place, and interiors are, everything has been designed for you. All you need to actually put a fuel and then start the car, right? You don't need to understand how ignition, sparking, the combustion within the mechanical engineering of the internal engine, and how it is actually boosting the power to push the car forward or backward, right? So these are all internal mechanics that is hidden for you. If you know some part of it, that will definitely help you. But if you don't know at all, you can still drive it, right? Because driving is something different than creating the internal mechanics of a car, right? So these are two different skill sets. So in this case, even though you are not familiar with all the internal maths and how the stats has been implemented, should be all right. You can just call the logistic regression library or class, provide the obviously the target attribute or column. In this case, obviously we have created class output, which is going to reflect that the what's going to be the outcome of the worker class or worker record, whether it's going to be above 50K or less than equal to 50K. And then if we are calling the fit method, like I mentioned in the previous linear regression video, that fit method take the data frame, it used the data frame, and then it used that data frame, and it build the logistic regression model for you. It create the internal mathematical equation for you. So then it can use that mathematical equation or algorithm to predict the values for the unseen, which is obviously our test data. And obviously we are keeping it into our log reg variable, which is just the instance of our logistic regression class. Now, all good, we have feed our training, so our model is ready. Now we are going to actually evaluate, okay, how good our logistic regression model is working on our training data set, and we are going to call the prediction method. And we are storing the result into the training result variable. Now that training result variable, it has 4 columns. Let me just show you the raw information about it. So display, I'm going to training result, right? And then I explain which one is. So you can see we have the feature, which is obviously the feature column that we have fed into the machine learning model. We have the class output, which is the result where we are getting the prediction. Then we have the raw prediction, which you can see we have 2 values. So these 2 values, like I mentioned, that is more like the probability. Because the logistic regression, once we discuss the introduction, we show that logistic curve, it doesn't return you the exact value. It returns you the probability that, okay, this guy, he's going to earn less than or equal to 50K. The probability is maybe 20%, right? Or this guy is going to earn more than 50K. The probability is 80%. Right, so obviously we know that the right information or the right value is going to be 80% in this case. So we are going to classify that person into the class where the person is earning more than 50K, right? So that's how we translate the outcome. but that is the raw prediction. And then obviously we have the probability, you can see, which is coming nicely with two values. One is associated for each class. So the first one is associated with 0 class, and the other one is associated with 1 class. And then obviously we have corresponding column, which is prediction, which is direct outcome of that probability. So like I mentioned, because the probability of class 1 is high, so we're going to predict it as 1. The probability in this case is high, obviously 0.37 for class 0, for class 0, and 0.62 for class 1. So prediction is going to be 1, and then same thing goes on. All right. So let's go back to now what we are going to do. We are going to see that, okay, how many records we do have where our prediction is equal to that, because in training, remember, we have all that information in place. Like we are not predicting the unknown or the new record. We are using the existing data set where we already know the value, right? So first we're going to see, okay, how many predictions are accurately predicted where the class output is 1. So what does it mean? The actual record value is 1 and our algorithm is predicting 1. And I want you to pay a close attention because you're going to see the number. So we have more than 1,000 record, right? So what I'm going to do, I'm just going to count them, right? Just for time being. I'm just going to, so I need to write down the counts, right? So let's see. So we have 2,669 records, right? So our model predicted 2,669 records correctly out of, let's see how many we have. So you can see we have 4,736 records. Records, right? All righty. So now I'm not going to associate the term because that's a separate topic. I'm going to actually record a separate video, right? So that is all good. Where we have the right value and our algorithm is predicting sweet spot. Now we are coming towards the problematic spot where we have the actual value 0, but our algorithm is predicting 1. All right, let's see. So it is also greater than 1,000. So I just need to know that how much it is. So we have 1,115. All right. So it still look good. Like it's not that bad. 1, 5. Right. So if I actually, what I'm going to do, let me, quickly do it in here. If I, just 1115 divided by 4736. So 0.23. So the accuracy is pretty good. Like it's not that bad. The accuracy is above than 70%, right? For where the class is 1. Where what we are saying, where we have the less data set, right? Now I'm going to do the same thing where we have the more data set, where we have the more instances for predicting or the class of workers who are going to earn less than 50K. All right, let's run this one now. So I'm going to now change it. I think that's the repetition. So 0. Right, so we are now going to see the other class where the person is going to lie in the class 0, or person is going to earn less than equal to 50K. Let's see. Oh, we have 13,765 records out of, and that's where we can go up and we can find we have the out of 14,880. Which is pretty good. Like I can tell you by looking, and we can do a quick math in here. So 13765 divided by 14880. You're gonna see, wow, we have 92.5% accuracy for our 0K. And if you remember, I mentioned that you need to consider the number of instances while you are preparing your data for your algorithm, because that really impact on the accuracy of the outcome, right? So you can see there's straight imbalance, and that's the impact the imbalance is doing on your machine learning algorithm, right? So we theoretically prove it that more data or more qualified data we have, that's going to actually improve the outcome. Obviously, we have almost double the instance, or not even 2 times, right? We have 2 times more instances. Yeah, we have 2 times for 3 that 12. Oh, 3 times more instances than the class 1. So obviously the accuracy you can see is much higher compared to the other class. And obviously, like I mentioned, the other case is going to be less. In this case, obviously, where we have class 0 and we are predicting class 1. Is it this? Let me see. No, I think I did some wrong in here. It's going to be this. My bad. Yeah. So yeah, so you can see we have the, yeah, in this one we know the actual output is 1, but we are predicting 0, right? So that's the inaccurate prediction where the class is 1, right? So let me see what count I'm going to get. Sorry, I actually put a wrong number. So we have 2067. All right, not 115. So let me just correct it. So let me repeat again. So in this case, the actual class output is 1, but our algorithm is predicting them as 0, right? So which is incorrect, right? And this one is going to be right, because our actual class output is going to be 0, but we are predicting 1. So that's the right one, right? So 1 1 triple 1 5. So that's how we look at the accuracy of the matrices. There are different matrices that we're gonna discuss in the next video. I don't want to start the conversation in here, but what I'm gonna do, we're gonna actually complete this video by running the same the same model on our testing data sets. So if I actually go down and I need to copy this statement above, right? I will explain all these in the next video. I don't want to confuse in this one. Yeah, so we have reached up to here. Now our training is all good, and we are ready for the real show. So we are going to run logistic regression model for testing data. All right, so, and how we are going to do, obviously we don't need to rerun the whole modeling because the model is already trained. based on the training data set. All we are going to provide now call the evaluate function, and that evaluate function is more like the absorber of the data frame where our data is, and then it absorbs that data and then it predicts the outcome, and that prediction is going to be exactly the similar fashion that we have seen above in the same schema. But it is obviously going to generate based on the testing data. All right, so let's run it and see what we're gonna get. So our testing results are ready. We're gonna display our testing result. So you can see the testing results are coming in the similar fashion, right? And now the only thing what we are going to do, we are going to run the same thing, but obviously from the testing perspective. So what we'll do, let me just copy one statement. Yeah, from here. And before even that, I'm just going to show you. Yeah, so that will help us to. Now what I'm doing, and I purposely kept it on the fly because I just want to show you on the fly so we can see it in the video. So obviously I'm now using testing, so I'm going to use testing BF. And I first want to show you the total number of records which we are using for our experiment. Let me show my testing results, and I'm going to copy this cell. So you can see our testing data set is obviously that's the 20%, so it's going to be less. And now I'm going to first check the accuracy of my class 1, where the actual value is 1 and we are predicting 1. So how many records we are getting? So you can see we are getting 2669. 2669. And by the way, if I actually calculate if I calculate the percentage of the accuracy, so 2669 divided by 4972, that's 53%. So we are getting 53% accuracy, which is not promising, but like I mentioned, you need to look at the total number of records that we are using in our data frame. All right. I'm just going to copy and I'm going to paste, but this time I'm going to see where the actual output is 1, and I'm looking at what's the total count where the prediction is not correct for class 1, where the worker is earning greater than 50K. So you can see the value is almost balanced, right? 2067, which is more like 47K. So close to half of the set is not coming correctly. And like I mentioned, we're going to actually see there is a reason with the imbalanced data set. Obviously we don't have many instances, so we can feed into our model. Now how we're going to prove it, we're going to now look at the other side, the accuracy of the other side, where we are feeding now. So we are going to check where the class value is 0 and we are predicting correctly as 0. So let's see what we're gonna get. Wow. Oh, sorry, wait. I think I did a mistake. Oops, I'm still using the wrong. Yeah. Sorry, my mistake. I'm using the wrong variable in here. Let's see. So testing results. Yeah, so we have 875. Right. And let me just see. Testing result, we are going to have 715. All right, so the ratio is almost the same, and you can see, yeah, 8 and 7. Sorry, that was my mistake. I was using the wrong variable. So we are evaluating testing, not the training one. So now but the ratio you can see is almost the same. It's not actually changing. Almost 50% of the records. That's why I didn't pick initially, because the accuracy is almost the same. Now, what I'm going to do in here, I'm going to do testing. Yeah, the prediction is 0, and we are going to see how many records we are going to get. We are getting 4602. Wow. So 4602, and we do have 4972. So let me do a quick math. 4602, 4972 is exactly the same as of the training. So our accuracy persists once we use the testing data. So that is 92.6. And obviously, if I actually, check the other side, that's going to be the remaining 8%, right? Which are not classified correctly. Where actual value is 0, but algorithm is predicting as 1. All right, so let me just run it to see how many records we are getting. So you can see only 370, which is maybe 6.4% of the 92. Now 7.4% of the data is not classifying correctly. So that's the logistic regression. We have seen really good accuracy. We picked up one issue with the imbalance data set and how it impact on the accuracy of the model. What we can do, we can run the same experiment where we have the balanced class. And we can see the impact on the outcome, where we can use both classes in a close to similar numbers. Maybe we can take one 10 grand or 10,000 from one side and maybe 13,000 from the other side, and then we feed into the model to see whether it's gonna impact on the accuracy. But that's a completely separate experiment. So now you can see how the machine learning world work and where the accuracy comes into the picture. So hopefully you will now understand how the logistic regression works, how we can prepare our data set and feed into the machine learning to let the machine drive the show and provide us the prediction. And tell you the truth, all we need to, so the model is there, all we need to we can use this notebook for any kind of logistic regression problem. All we need to get the data, prepare the data, and then feed into our logistic regression model. One tip I would love to share that whenever you start with machine learning algorithm, please start with small, get the accuracy, validate the things, and then slowly increase the complexity until unless you are completely professional with what you are doing, you know what you are doing, and you are confident, then you can open the floodgates. Like you can add as many features you want to to check the accuracy. But in the initial step, always start with small, because if things are not going according to what you are expecting, at least you have an opportunity that you can investigate and identify the issue. So hopefully this video will be beneficial for you in your machine learning journey or in your machine learning job or even in your interview. Thanks for watching. I hope you like the video. Please like or put any comments if you have any question. Otherwise, we're gonna see in the very next video, which is very important from the accuracy perspective. So now we know we have the information. How we going to determine the accuracy of our model, whether our model is good or bad? Can we use it into the production? Do we still need to improve in the diverse staging environment? All right, so in order to address these kind of questions before we hand over to the production team, we have couple of matrices that we use to determine these value, which we're going to discuss in the next video. Thanks for watching.